Maximum power transfer theorem. Maximum power transfer theorem states that the maximum power is delivered from a source to load when the load resistance equals to the source resistance. Let us consider a network with voltage Vs and a source resistance Rs and variable load resistance RL. Then the current in the circuit is given by I equals to Vs divided by the total resistance, that is Rs plus RL. Then the power delivered to the load RL, that is P, is equals to the current square of R, L, Vs square RL divided by RL Rs whole square. Maximum power transferred to the load is given by dP by d RL equals to 0. Now differentiating this term with respect to RL, so it's just a partial differentiation, then you are going to get Vs square of RL plus Rs whole square minus 2 RL Rs plus RL divided by Rs plus RL whole to the power of 4, which equals to 0. In this equation, Vs square of RL plus Rs whole square minus 2 RL Rs minus 2 RL square equals to 0. RL square plus Rs square plus 2 RL Rs minus 2 RL Rs minus 2 RL square equals to 0. Rs square minus RL square equals to 0, or Rs equals to RL. This is the condition to get the maximum power delivered to the load, and this is applied in radio, speakers, microphones, where the signal need to be amplified. But usually the voltage is max when RL is max. Current is max when RL is minimum. But power is max when RL equals to Rs. Determine the maximum power delivered to the load for a given circuit. This is our circuit. So we need to find out the maximum power between these points A and B. The first step, we need to find out a Thevenin's equivalent circuit for this between the points A and B with an voltage VTH, and this is RTH. Then we can equate the RTH to the load resistance. Now, finding VTH, voltage at point A is given by the voltage 100 multiplied by 30 ohms divided by 30 plus 10 ohms. 100 into 30 by 40, 75 volts. Then the voltage at point B is 100 applied voltage multiplied by 40 divided by 40 plus 20. 100 to 40 by 60, 66.67 volts. Then VAB equals to 75 minus 66.67, which equals to 8.33 volts. Our VTH is 8.33 volts. Now we need to find out RTH. Redraw this. Then 10 and 30 in parallel plus 20, 40 in parallel. This is RTH. That equals to 10 into 30 by 40 plus 20 into 40 by 60. 300 by 40 plus 800 by 60. Then RTH equals to 7.5 plus 13.33, which equals to 20.83 ohms. So this is 20.83 ohms. The maximum power occurs at RL equals to 20.83. Then the current I through the load 20.83 is given by 8.33 divided by the total resistance, that is 20.83 Rs plus RL is again 20.83, which will be equals to 0.2 amps. The maximum power P max is given by I at 20.83 whole square multiplied by the RL. Then 0.2 whole square 20.83, which is nothing but 0.04 multiplied by 20.83. If you do this, you are going to get 0.833 watts. This is a P max. Determine the maximum power delivered to the load of a given circuit. This is a given circuit. We need to find out the maximum power across these two terminals A and B. Then we need to find out a Thevenin's equivalent circuit between the points A and B with RTH and VTH. The total resistance of this circuit without A and B, 3 plus 2, which is in parallel to, of 5 plus 10, which is the total resistance of this circuit, which is given by 5, and 5 is in parallel. So 5 into 5 divided by 5 plus 5 is 10 plus 10, or 2.5 plus 10, which is equals to 12.5 ohms. Current through the circuit is given by total voltage 50 volts divided by 12.5, which is nothing but 4 amps. We need to find out the voltage between A and B. Then we need to find out the voltage between 3 ohms. Current through 3 ohms is given by the total current multiplied by opposite branch resistance divided by this branch resistance, that is 5 plus this is 3 and 2 is 5, 2 amps. Then the voltage across 3 ohms is given by 2 amps into 3, that is 6 volts. So VTH is 6 volts. Now finding RTH. From this, then 10 in parallel with 5 plus 2, this is in parallel with 3, which is RTH. If you find out this, you are going to get 1.92 ohms. So RTH 1.92 ohms. Load resistance is also equals to the RTH or the source resistance, that is 1.92 ohms. Then the current through 1.92 ohms is given by the voltage 6 divided by 1.92 plus 1.92, which equals to 1.56 amps. P max, maximum power, equals to I 1.92 whole square into RL, that is 1.56 whole square multiplied by 1.92, which equals to 4.67 watts. So P max is 4.67 watts.